Okay, so we have some more vocabulary here. I'm going to go through some of it kind of quickly. A term is a number like 7, or the product of numbers like negative 3x squared y, which would be the product of numbers and variables raised to powers, or you could just have 10a. Those are all terms. Now, whenever you're multiplying two binomials, like x minus 3 is a binomial and x plus 7 is a binomial, that is the FOIL method. Also, notice here it has the word binomials. Well, that's exactly two terms, right? So binomial is exactly two terms. 3 terms, I think that's maybe obvious, right? Exactly 3, that would be trinomial. And then also we have mono, like monopoly means one person owns everything. So that would be exactly 1 would be a monopoly. A monomial, and exactly 3 would be a trinomial. All right, so the ones that are kind of tricky can be degree of a term versus degree of a polynomial, but it says here the greatest degree of any term of the polynomial. So the word polynomial here, and I'm going to just abbreviate it, degree of a polynomial is the greatest degree of any term. And we're going to see this here a little bit later on a problem, and that'll explain it more. Whereas degree of the term is the sum of the exponents on the variables in the term. And like I said, we're going to get to look at that problem when we do number 39. And then the coefficient of a term is its numerical factor. So like 7xy, 7 would be the coefficient. Or negative 10, a squared, b squared, negative 10 would be the coefficient. Let's see. All of these are polynomials. And to multiply this thing, we use the distributive property. All right. So let's get into some questions. The first one here, 5 to the negative second power, that is going to use the definition for negative exponents. If you remember, negative exponent says if you have some base to a negative number, then you can make that a positive exponent by flipping it. Also, it's true if it was the other way around, meaning if your negative's in the bottom, you would flip it to the top. And so remember, this is over 1. So when I flip this, I would get 1 over 5 squared. Well, now I know what 5 squared is. That's 25. So I end up with 1 over 25. All right, so number 34, I'm going to rearrange some stuff. I'm going to group together negative 4 and 4 because those are numbers. And I'm going to group together x to the 4th times x to the 5th. So because all I'm doing on 35 is multiplying, I can multiply in any order I want. And this is the order I want to multiply in. And this is the group I want to multiply in because I know negative 4 times negative 4 is 16. And then if you think about it, this is 4x's times another 5x's. Well, isn't that just 9 altogether? So this is the case where we add those exponents together. So on 35, what I did was I added my exponents together. So I did x to the, I'm going to kind of show that step. Oh my gosh, that's not the eraser. So I did negative 16, x to the 4 plus 5, because when you multiply with the like bases, you add the exponents and you keep the base. 36 is the one that says, what do you do when you divide like bases? Well, when you divide like bases, the shortcut is to just simply subtract. And so here I would get 4 minus 3, which is 1, but we're just going to write that as x. But I think it's important to note that what happened here is we had this in our numerator divided by this in our denominator. And so each of these were really 1s, right? And so all those 1s don't change anything, and I'm just left with x. All right. 37 has a bunch of stuff to an exponent out here. Well, that is the power rule. So we on 35, I use the product rule, which says x to the m times x to the n is x to the m plus n. On 36, I use the quotient rule, which says that x to the m over x to the n is x to the m minus n. And on 37, I'm going to use the power rule, which says x to the m to the n is the product of those exponents. So when I look at this example, I really have x to the first power, y to the sixth, x to the fifth, y to the first to the negative 2 power. So I'm really literally coming in here and I'm multiplying all of my exponents, top and bottom, by negative 2. So that's 1 times negative 2. So I end up with x to the negative 2, y to the negative 12, x to the negative 10, y to the negative 2. All right, so now that I've got my power rule done, I notice that I have a bunch of negative exponents. So watch what I'm going to do. I'm going to make my negative exponents positive. So you see this x to the negative 2? I'm going to put it down here. Now it's positive. Do you see this y to the negative 12? I'm going to put it down here, and now it's positive. X to the negative 10 is on bottom. I move it to the top, and it's positive. Y to the negative 2 on the bottom, I move it to the top, and it's now positive. So now I'm able to use, I don't need the product rule, but I can use the quotient rule. So here I'm going to subtract my exponents. And when I do this, I get x to the 8, y to the negative 10. Well, I don't want y to the negative 10. I want y to the positive 10. And so that means that I'm going to rewrite this by moving that y to the negative 10 to the denominator, and now I've got it as a positive exponent, which is what I wanted. All right. I think 38 to me is actually a little bit easier. The first thing I notice on 38 is that I want to, everything that's negative, I'm going to move. So do you see these negative exponents? They're going to get moved. So all of this is going to flip. But that y to the third and that y to the sixth is going to stay where it's at because it's already positive. So I'm going to move. So I have 5 to the negative 8, move it to the bottom. X to the negative 2, move it to the bottom. 5 to the fifth, x to the fifth. So now is a matter of subtracting my exponents again. Well, when I subtract my exponents, I end up with 5 to the negative third, x to the positive third, y to the negative third. So the only positive exponent I see is x to the third, meaning the other two, the 5 and the y to the negative third, is going to go to the denominator. Also notice that could be 125, right? That could have been x cubed over 125 y cubed. I would accept either one. Okay, so that gets us now to this idea of degrees and such. So, for each term, the coefficient is nothing more than the number in front of the variable. So here my coefficients would be 2, -7, 3, and -1. The degree of the term is going to be the sum of the exponents. But the exponents have to be on the variables. So if you look at the first one, 2x to the first, y to the second, if I add those exponents, what do I get? 3. And then if I look at -7, x7, y7, z to the first, well, 7 plus 7 plus 1 ends up being 15. And then 3x cubed y to the first would be 3 plus 1, which is 4. And there's absolutely no x on this last one. That would be the equivalent of saying x to the 0. which is 0. And so that's the degree of the terms. But the degree of the actual polynomial, which is this whole entire thing here, this whole thing is the polynomial. The degree of the polynomial is the largest out of all those terms. So that would be 15. Now, let's talk about adding and subtracting. So, with a problem like number 40, you have some options here because you're just adding. Personally, I like to stack them up. So I'm taking my first polynomial here, boop, and then I'm going to add that to this polynomial. So I'm just going to be adding. Those are like terms. Those are like terms. This is awesome because I got a lot of like terms here. And then I'm just going to be adding them up. So 3 plus 5 is 8. 2 negatives, you add and keep negative. Notice I'm not doing anything with the exponents. If you have 3 widgets plus 5 widgets, you have 8 widgets. So all you're doing is adding those coefficients. So here, when I see a negative and a positive, I'm going to take the difference and keep the sign of the larger number. So the difference between 9 and 2 is 7. The larger number is negative. But you can always use a calculator on something like that. Of course, that's 12. Now, I'm going to do the same thing on this problem, except for, notice I'm subtracting. And so what I'm going to do is I'm actually going to end up adding the opposite, meaning that I'm going to take my 6x to the 9th plus 4x to the 8 plus 6x to the 7 plus 9. So that is my first polynomial. But now I'm going to change from subtraction to addition. But that means I'm going to have to change all of my signs here. So that's going to now be negative 2x to the 9th, positive 2x to the 8th, positive 2x to the 7th, and then minus or negative 1. Because again, over here we were adding. And so I want to be adding. And adding means to do, subtracting means to add the opposite. So literally add the opposite. Well, notice in here that was positive 2, then negative 2, then negative 2, then positive 1. And you'll notice down here I just did the opposite signs. And so now I'm ready to combine. 6 and negative 2 added together, or just simply 6 minus 2 would be 4. 4 plus 2 is 6. 6 plus 2 is 8. And 9 minus 1 is 8. So that's pretty awesome. Okay. The next one. Now we're getting into distributive property. So when I see a problem like 10x cubed times 5x to the 4th plus 12x cubed plus 2, now I'm going to be multiplying everything in my parentheses by 10x cubed. So I'm going to have 10x cubed times 5x to the 4th plus 10x cubed times 12x cubed plus 10x cubed times 2. So now, individually, if you notice here, this is all just multiplication. This is all just multiplication. This is all just multiplication. So within each of these 3 terms, I will be multiplying the numbers and adding the exponents. Multiplying the numbers and adding the exponents. Multiplying the numbers, and there's nothing to add there. So again, I'm adding exponents this time because I'm not combining like terms, I'm multiplying. All right, number 43, this is a classic FOIL problem. So for those of you that like the FOIL technique, then what you are doing with the FOIL technique is simply you're multiplying your first two terms together. So here that would be x times 3x, which is 3x squared. Then you're multiplying your outer two terms together, which would be x times negative 8 or negative 8x. Then you are multiplying, of course I don't have room, then you are multiplying your inner two terms together. Negative 6 times 3x is negative 18x. And then last but not least, you are multiplying your last two terms. Man, I wish I had a good, I hope this is bright enough. But you're multiplying negative 6 times negative 8, which is positive 48. Now I notice that the two terms in the middle are like terms because they both are just x's. So when I combine the two negatives, I just add and keep it negative. And so there is my FOIL problem. Also notice that I could have worked it like this, where I just stack them. And I say, okay, it's like big old school times. That would be a positive 48. And negative 6 times 3x is negative 18x. Then I do a 0. And then x times negative 8 is negative 8x. And then x times 3x is 3x squared. And then I'm just stacked and ready to add. So those are some options for that one. For the next one, I need some more space here. For this one, you can do the distributive property technique. So for number 44, you could definitely set it up as 9x minus 1 times x squared minus 2x plus 1. Or you can stack it and multiply. So either way, you're going to get the same result. If I stack it as I go, then I'm going to do 1 times negative 1 is negative 1. Then I'm going to multiply those two together, negative 2x and negative 2x times negative 1 is positive 2x. And then I'm going to multiply negative 1 times x squared, which would give me negative 1x squared. Now I'm going to put a 0 as my placeholder, and I'm going to do the same thing with the 9x. So 9x times positive 1 is positive 9x. Then I'm going to do 9x times negative 2x is negative 18x squared. And then 9x times x squared would be 9x cubed. Move this over just a hair. And so now I can just add my like terms because they're already ready to go. So I end up with negative 9x cubed minus 19x squared plus 11x minus 1. Or, so that's one way. If you don't like that way, that's fine. Or you can first do this. You can distribute the 9x, meaning you can do 9x times x squared minus 2x plus 1. And then you can distribute the negative 1, so that'd be negative 1 times x squared minus 2x plus 1. Meaning I'm going to get 9x cubed minus 18x squared plus 9x. And then minus 1x squared plus 2x minus 1. And then notice that I have some like terms, right? I've got the minus 1x squared and the plus 9x, which I'm going to switch around here, which is totally legitimate. Because now I can combine. So I've got 9x cubed. And right there, I've got my minus 19x squared. Here I've got my plus 11x, and then minus 1. Also want you to notice over here that it's the same thing I got in pink and blue right there. So same thing. Just a different way of setting up. All right, the next one, 45, is going to be a FOIL problem. This one is very, very easy. To miss or to forget. I see students do this all the time. They'll just want to do 7x squared minus 9 squared. But this is 7x minus 9 times 7x minus 9. So if I do first, I get 49x squared. On the outside, I get, because 7 times 9, and that's negative, so negative 63x. I get another negative 63x here, and then I get a positive 81 for my last terms. So if you were to do just first, outer, inner, last. Now you can simplify this because the two middle terms can be combined. And so when I add those 63s, I add them and keep it negative. And now I've got my final answer. All right, 46 looks crazy hard, but it's not. All 46 is asking you to do is to plug a number into this expression here. So you can read all you want, but they tell me t is 3, and they give me an expression with t in it. So all you're going to do on this problem is you're going to replace the t in that equation with 3. And then you're going to say, okay, well, first the order of operations says I'm going to square that. And then, of course, you can put a lot of this in the calculator. That would be negative 144 plus 600, which is really this. And so, let's see, so 656, so 456, and it is in feet, and that's it. All right, the last thing we covered in this unit of notes, dealing with exponents and such, polynomials, was a divide problem. But we are just dividing by a monomial. So that means that you are allowed on this problem to break it up. Now, the ones I gave you on your homework were easier. I really didn't mean for this one to be this weird. But all I'm doing here, guys, is this. I'm just dividing. So I'm just reducing these. Like, that's 1 and that's 3. And then I can take out an x. So for this first term, I end up with x over 3y. That's what's left when I simplify. On the next one, these are going to divide out. And then when I reduce 3 over 18, I get 1 over 6. So that's going to be plus 1 over 6. And on the last one, the only thing I can cancel out is my x squared. So I'm just left with minus 17 over 18y. I'm going to give you one more like your homework where you don't end up with like everything a fraction. Meaning it might be something more like this, but like if this were 18 and this down here were just 3y. Or 3x, I'm sorry, then you wouldn't have had all that craziness. So just real quickly, what I want to say is this. If I had 6x squared plus 18xy minus 7x all over 3x, then it would have simplified a lot nicer. Because on this first one, you would have just gotten 2x. Here, you would have gotten 6y, and then minus 7/3. So this is a little bit easier. All right, so that's going to be that one.